like in case any of you have doubts in between, like instead of writing in the chat, just unmute yourself and ask me then and there. Like I'll try to resolve all your doubts at that moment only. Okay. Instead of like, you shouldn't wait for me to completely discuss the problem and then like, then once I'm like going to the next problem, then you're asking your doubts. So let's start. Let me know when my screen is visible. Okay, my screen is my screen visible?
Yes, your screen is visible.
Okay. So the first problem is really simple. You just have to check if x is like, if you can go from x with floor to y with floor via stairs. So for stairs, like moving, you can move up. If you just have to move 2 floors up, then you can use stairs, or you have to move down at max 3 floors. So that is what you have to check in this problem. So I'll show you directly the implementation. So this is the implementation. Hopefully no one is having doubt in this, right? So going to the next problem. So the next problem is a 326 like number. In this problem, we have to find the closest integer, like the smallest integer, which is more than or equals to 326, like which is more than or equals to n, and it follows this thing, like the multiplication of first two numbers is equals to the third number. So as like we know, what is the number which is 326 after 919? Can anyone tell me? What is it?
This is the last number.
Which number?
Is 919.
So after this, yes, basically 919. If like 919 is 312, 326 number, like right? I'm saying, I asked you if n was 3919, your answer will be 919 only, right? Because this is a 326 number. 9 into 1 is 9. So basically any number between 1 to 919, at like, what is the worst case? Like worst case is the answer is 919. So what we can do, we can iterate from, like, let's suppose we are given n in input. We'll just keep doing n plus plus and we'll check whether this is a 326 number or not. So how many iteration we have at, like, it is in order of 10 to the power 3, and we are checking just 3, like for these 3 digits. So something like this. So this is just simple brute force. So this is the implementation. Just while the check fails, just like keep doing n plus plus, and inside check I'm doing nothing but I'm just multiplying the first 2 digits and I'm checking that it is equal to the last digit. So for whatever number check passes, and I'm going to bring that in. So going to the next problem. In this, we are given that Takashi has n gifts and the ith gift is placed on the number line on the coordinate AI. Now, we can choose a half open interval, that is from x to x plus m, not including x plus m, of length m, on the number line and acquire all the gifts included in it. So we have to maximize the number of gifts that we can acquire. So first of all, see, if we sort these values, AI values, so what is the point of starting the interval from here? Like if let's say this is 1, 3, 4, 5, 9, 10, 11. If I like x is fixed, but the point is if I fix this thing also where I'm going to start, my ending is also fixed, right? But the point is how to fix this. See, it never makes sense to start my segment at 2. I'll start it at 1 or 3. Like what is the point of having this thing, right? There is no gift here. Or I'll start at 4. So we'll do the same thing. Once we sort our array, we'll try to start our segment from here, and till which position we can go till x plus m. So all the values which are less than x plus m, let's suppose m was 8, so x plus m like is 11. So all the values less than 11, like all the gifts which are like in this range are can be received by us if we choose this as our starting point. So first of all, how to find this, how many gifts lie in this range? We can simplify this using binary search. Okay, and finally our answer is nothing but maximum of all of these, like whatever we get by starting our segment in each of these positions. Is it clear? Is it clear? Yes, no?
Yes.
Okay, so let me show you the implementation. So this is the implementation. Just sort your array. Then for each index, find the place that cannot be included in the answer, like cannot be included in the current segment. And if you subtract this much from it, like you'll get the number of gifts that you can have. So this is just binary search, simple binary search using lower bound. So finally your answer is nothing but maximum of answer or x. So now no one is having doubt in this, right? So let's go to the next problem. So in this problem, we are given that we are given a string n and a string r and c of length n. Now, these strings r and c consists of a, b, and c, and we have to solve the following problem. In this, like there is an n cross n grid, and all cells are initially empty. Now we can write at most one character from A, B, C in each cell, and we can also leave a cell empty. So we have to determine if it's possible to satisfy all the condition as follows. And if it is possible, we have to print one way to do so. So each row and column must contain exactly one A, B, and one C. Then the leftmost character written on the ith row should match the ith character of R, and the topmost character written on the ith column should match the ith character of C. So let me show you this example. So see, in this first row is having A, C, B. So in this string, at first place you have A, in the second place you should have C, and in the last place you should have B. The columns which have been left out, that don't matter. And same way for this thing, A, C, and B. So at the first place, the first string is having A. On the third place, it is having C. And on the second last place, it is having B. So this should be satisfied, like the first row and first column. Other than that, the complete grid should have in each row, it should have at max, like exactly one of ABC, and exactly one in each column, it should have exactly one of ABC. So first of all, if let's say this is a grid, like in worst case, the grid is having 5 sides, right? And how many options do we have for each place? How many options do we have for each place? So how many options do we have for each place? We have 4 options, right? Either it can be left empty, or it can have A or B or C. So if I do a complete brute force, I have 4 options here, 4 here, 4 here. Like this way, I have 4 options for each and every cell. Then finally, once I get a grid, I can simply check whether that grid satisfies all the condition or not. How? Just check in each row and each cell. Every character is appearing exactly once, and the characters that are written in these columns, like in these rows, in this row, matches the string R, and it matches the string C, and here it matches string R. So, but what is the time complexity for this? It is 4 to the power 25, right? Yes, no. Is this making sense?
Yes.
Okay. So this will clearly give us a TLE. Now, how to optimize this? See, first of all, it is 4 to the power 25 into 25, because 25 for checking. So first of all, how to remove this? We won't go in that direction in which we are sure that we have a wrong answer. So basically, if you already have a, there is no need to put another a in this row or like in this row or this column, right? Because those are wrong. Then secondly, I just have to first, let's try to fix a. Like after that, it's just brute force. First try to have the all the rows and columns have a, then b, and then c. Once this is done, you can print. Once you have made sure, like once you have made sure that every row and column is having a, every row and column is having a b, and every row and column is having a c, and none of the conditions get violated. Like this R and C conditions, string conditions are also not like they are also not invalidated, and all the conditions that are here are also met. So if you never took a wrong step, then at the last you also don't have to check for this, and by this way this will actually get you a correct answer. Like this will pass all the test cases. It's just complete brute force. Some, like we are doing the same thing, but we are just not taking the wrong direction. So first of all, for if you are doing this separately, for how many options there are when I'm doing for a, there are just two operations, right? So instead of four, I won't have four any time. I'll have two. I will be doing this for each one of these. First I'll do for a, then I'll do for b, and then for c. Is it clear? And then also I'll just check one thing, that this row or this column is not having that a earlier. Is it clear? So if you try to find the actual time complexity, each row and each column, like row is having 5, and the column, like each row, in worst case, like 5 into 5 plus 5, like for this row and this column. I'm just talking about this row and this column. So out of this, only 2 cells, at max 2 cells will have. So number of ways to choose, like how many ways there are to choose 2 cells out of this. And then after that also, if you chose this cell and this cell, you are not actually blocking just these 2 rows and columns. You're also blocking if you choose this and this, right? So that's why the time complexity will be less. Can I show you the implementation? Yes, no, anything? Okay. So see, first of all, take nRC in input, then currently everything in the grid is having a dot. That is, nothing is, none of the characters is there. Now just apply this brute force. Now in this brute force, currently I am at this row, and like I'm at this thing, and now will tell me if now is 0, I'm trying to fill A. So first of all, if now is already 3, then you can check whether the grid satisfies or not all the conditions, like just to have a final check. And in this also, we are just checking the same thing, like what we are doing. See, if temp is 0, and then for each row, we are counting for how many times, like like grid of for the first row, and for like this is just for the first row and no, the first row and the first column. So this we are just checking that if it is not a dot, then it should be equals to R of I, and if it is not a dot in the first row, then it should be equals to C of I. So this is for first row and this is for first column. Okay. Otherwise, what we can do, if this thing is not equals to a dot, and we have already like pose of now of I is simply that we have this now means either A, B, C, one of these is already in this ith row or column. Then we can simply continue, because in this place we cannot have this, right? Otherwise, we'll first try to make this LV. LV is nothing but the row, and I is currently working as my column. So this will be A plus now. So now was initially 0. So basically A. If now is 1, so B. And if now is 2, then this is C. And if now is 3, then I can simply just check. And if I find my answer, I'll simply print it. So first of all, I'll substitute this as this. Then I'll change this. Like now I have this character at ith row, at ith column. then I'll again call the recursive function. And once I return from that, I'll undo what I have done. So making it back to dot, and now this is 0. So basically this is also a brute force only, but we are doing it smartly. Is it clear? Like if there is any doubt regarding this implementation, you can ask me. And like if you have doubt like this, what is being done here? So if LV is n, then basically we have LV is n. What does this mean? That we have gone from 0th row to n minus 1th row. And now we are going to this character. Now I'm completely done with A. I'm going for second B character. Instead of doing this, you could have also called this function 3 times here. Like for one for A, one for B, and one for C, instead of passing now here. So this is for the first, like once LV becomes n, like LV is nothing but kind of level. So level becomes n, like 0 to n minus 1 you have filled. So this will become now plus 1. That means from A character, it will become B character. And now you are again going to the 0th row. Is it clear? So this is the same implementation that I have earlier shown. Is there any doubt? Is it clear to everyone? Okay. Okay, so let's go to the next problem. So in the next problem, we are given that like a koi, an employee at Atcoder, has his salary for this month determined by an integer n and an array of size n. Now, first, he is given an n-sided dice, then that shows an integer between 1 to n with equal probability and a variable x equals to 0. Then he follows the following steps, and like until these steps get terminated, he follows these steps. If x is less than y, like let's say he rolled a dice and he got y. So if on the next time he got x which is less than y, he'll get ay, and now x is equals to y. And otherwise terminate the process. So basically, like, so let's take this example. Let's say these are a. So on the first, let's it show 1. So now let's, if 0 is less than 1, he'll get a1, and now x becomes 1. At the beginning, x is 0. At the beginning, the x is 0. So what is happening? Let's see in this. See, at the beginning, everyone has a possibility. Every of these have a possibility of 1 by n, right? Yes, no. Like at the beginning, your dice, like first of all, x was 0, but then y can come any of these, right? Yes, no, anything.
Yes.
Okay, yes. So what does this mean? That okay, let's say this, like everything can come like this, and now what is the how what is the chance of, like, after once you get 1 by n, what is the probability that you'll end here? What is the probability that will end here? Like, first of all, your x became this thing. Earlier your x was 0, now x is 1. Again, you should throw the dice and it should come 1, right? So the probability of getting just this a of 0 or a of 1 is nothing but 1 by x, 1 by n plus 1 into 1 by n. Is it making sense? What about this thing? For this, you will get a2, first of all, because if it is 1 by n, and then any of the last two, if any of the last two comes, 2 by n, plus when you got a1 by n on the first time, a1 by into 1 by n on the first term, you got this much. Then on the next term, you got this thing, 2, as in your like dice. So in that case, what was the probability of this complete thing happening? Like, your final score will be a1 plus a2, but what is the probability of this happening? It is nothing but a1 plus a2. Can someone tell me what should be down here?
Can you explain once again?
Okay, I am saying that you have told me that the probability of getting the score, like on the first time you got this thing, like every index is having 1 by n as probability. So the score of each of these, like this is the salary that, like probabilistic salary that he'll get. But let's say now I'm saying that after this, first he got excess this, now he got excess this. So what is the salary? Salary is nothing but a1 plus a2, right?
Yes.
On the first dice turn, he got this as the number. On the second dice turn, he got this as the number. Salary will be a1 plus a2, right?
Yes.
What will come in the denominator?
N into n minus
N into?
n minus 1.
Perfect. Why n into n minus 1?
Because
Why,
even will
why,
not.
why n minus 1? Like n is okay. Why n minus 1? Why did you reduce your total number of outcomes? Like dice is still having n, right?
Yes.
So the first time you throw, you had n options and you just wanted this, so 1 by n. Next time you threw the dice, you again had n options and you're only interested in 1. So shouldn't it be n square, 1 upon n square?
Yes.
So this thing. Now you can see this is not just for 2, but this is for a3 also. a1 plus a3 n into n, and same thing like everyone. But one thing that will also come in a3 is, like on a1, it was just, for a1, it was just a1 by n. For a2, it is a2 by n plus a1 plus a2 by n square. For a3, can you tell me what it will be for a3? It will be a3 plus an, of course. Then like a3 by an, a3 by n. Then these two terms will also come, and then there is one more term. Which is it?
A1 plus A2 plus A3 by n cube.
Perfect. So a1 plus a2 plus a3 by n cube. So now this is what you have to calculate eventually. Like, these are the values. How to calculate this? Like, are you able to see some kind of pattern? Like, let me make it more clear. See, in this, I can take, this is nothing but take a1 common, it is 1 by n. Take, like, what is, how can we write this? We can write this as a2 1 by n plus, what is it? 1 by n square plus a1 by an, right? Same thing. So basically this thing will come here. Then what is this? This is nothing but a3 1 by n plus 1 by n square plus 1 by n cube. And then this is not a1 by n, like this is a1 by n square. So if I write here down, I'll get a2 by 1 upon n square plus 1 upon n cube. And same thing I'll get for a1 also. Yes, no, right? These are the terms.
Yes.
Like, is anyone having any doubt till now? How did I got these terms? So now if you calculate a4 also, basically what we are doing for the previous terms, we are doing the same thing without 1 by n, and for this term, this will get added to this, like will get multiplied with a3. And so what we can do, we can find the individual contribution, like for individually we can find for each of these terms what is the contribution that they'll have in the final value. Are you getting my point? Like, let's say we are able to find for the ith term how much it will contribute. So like basically the term which is getting multiplied by ai, and then we can add each of these from 1 to n ai into that term, that for term for the ith, and we'll add that to our answer. But how to calculate that? Like basically I want something that I can multiply with the aith term, and that will be the final contribution of aith term. How to calculate that? See, we can get this. Let's say first, for the first time, I have 1 upon n. Then for the next time, I have 1 upon n multiplied by 1 upon n. Then for the next time, the sum of these, whatever was the sum of these, 1 plus 1 upon n. Let me write this again. So whatever you have in the past multiplied by 1 upon n plus 1 upon n. So this is the second term, this is the first term. Then 1 upon whatever you have in the past. So you have 1 upon n plus 1 upon n square plus 1 upon n. Multiply this by 1 upon n and add 1 upon n. So why I'm doing this? Basically, this is the term that we are getting, right? Look, what is this term? This is nothing but you'll get 1 upon n cube here. This is 1 upon n square, 1 upon n square. So 1 upon n square and 1 upon n square, and you're getting 1 upon n also. So this is 1 upon n. Is it making sense? Yes, no. Like, what about others? Like, you just have to decompose this somehow. So let me write it again. Let me see. First of all, let's say you can maintain two variables, val and something like dp. So initially everything is 0 for these two, and then what I'll do, I'll go from 0 to n minus 1, and val, first of all, what will be my, I'll write dp. So first of all, dp of I plus 1 is nothing but sum. Let's say I have dp and sums. These are the two arrays. Sum of I into 1 upon n plus 1 upon n. Okay. And for the next time, I'll change my sum. So sum of I plus 1 is simply dp of
I.
No, not I. dp of I plus 1 and sum of I. Like, so if I write this down, see, let's see what we are getting. So for first, dp of I will be simply 1 upon n. For the next time, we are getting 1 upon n multiplied by 1 upon, this was from the previous time, and I'll add 1 upon n. Then this is from the previous time, add 1 upon n square plus 1 upon n into 1 upon n plus 1 upon n. So this is nothing but n cube, n square, and n. I think I wrote an extra n here. Yes, I wrote this extra n here. So basically you're getting n cube, n square, and n. So n cube, n square, and n. For these A2 and A1 you have already done. Like this is for A1, this is for A2, and this is for A3. Like this, if you keep calculating this, you'll get for each term what is the contribution. Is it clear?
Yes.
Like these problems are not that much intuitive, like that's why it's a little hard to explain. So anyway, so this is just inverse of n under mod. This is taking input, this is calculating those two arrays. So for each, sum of I into inverse 1 by n plus 1 by n, and sum of I plus 1 is nothing but sum of I plus dp of I plus 1. That is the term we've already calculated, because that sum of I plus 1 will now be used for dp of I plus 1. Okay, so now the answer is nothing but answer plus the contribution of ith term into ai, and we can take mod. So like try to, like you'll have to solve the problem on your own, like try to understand what I have done, like what I have explained, and then try to solve this on your own. Then only you'll get the complete approach. Otherwise, like trying to get an intuition for this problem just by looking at editorial or just by watching a video, like, it's really hard. So anyway, we can stop now, and thanks for joining. Bye bye. And you don't have any questions, right?
No.
Okay, like in case when you try to solve this problem and you're stuck anywhere, just like maybe tag me or any other mentor, and surely someone will help you. So
Thanks.
bye bye.